You know that moment during a test when you think, I wish I could go back in time and actually study for this? Well, I've definitely been there. And that got me wondering, is time travel even possible? If you're curious too, stick around because in this video, I'm going to break down everything you need to know about time travel. Starting with the most important question, what is time, really? Time is a complex concept. It's often described as a measurable period, something we track with clocks and calendars. But more than that, time is a continuum, meaning it flows continuously without any breaks or gaps. Unlike space, which is three dimensions, length, width, and height, time is usually considered a single dimension, moving in one direction only, forward. The second law of thermodynamics introduces us to the concept of entropy, a measure of disorder or randomness in a system. More technically, entropy tells us how much of a system's thermal energy is spread out and unavailable to do useful work. The higher the entropy, the more disorganized the system becomes. Now, think of entropy as the level of messiness in a system. To visualize this, imagine placing 100 coins on a table, all showing heads, a perfectly ordered state. Now, if you kick the table, the coins will scatter into a random disordered arrangement. That's entropy in action, going from order to disorder. What do we mean by time travel? To understand time travel, I want you to imagine this. A wine glass falls to the floor and shatters. Each shard flies off in a different direction, each with its own speed and path. Now, to reverse time and bring that glass back together, you would need to reverse the motion of every single piece, perfectly adjusting each shard's direction and velocity, so they come back together into the original glass. That's essentially what time travel would mean, undoing all the changes and movements in a system, right down to the tiniest detail, as if rewinding reality itself. The arrow of time refers to the one-way direction in which events unfold, from the past to the future. Earlier, I talked about the shattered wine glass, but here's the question. Why can't we just reverse the process and reassemble the glass? Your first instinct might be to blame the laws of physics, but surprisingly, that's not the reason. Take this. If you throw a ball into the air, it goes up and then comes back down. That reverse motion is totally allowed by physics. The equations work the same in both directions. So what's stopping the wine glass from unbreaking? Well, the answer is entropy. To understand entropy completely, accept this simple truth. Systems naturally evolve from order to disorder. That's the general trend. For example, picture a tight cluster of air molecules in one corner of a room. If I wave my hand through them, the molecules scatter and spread out. Now, it's not impossible for them to all gather back in the same corner. It's just so unlikely that it practically never happens. Now, let me explain it with probability. Imagine flipping 1,000 coins. If you flip, for example, 25 of them randomly each round, over time the ratio will almost hover around 50-50, half heads and half tails. Yes, it's technically possible to get all 1,000 heads, but the chance is so incredibly low that it's practically zero. Ordered states, like all coins being heads or all air molecules gathering in a corner, are possible, just extraordinary, improbable. And that's the arrow of time. It's not that physics forbids time reversal, it's that entropy makes reversed states so rare they may as well not happen. Even Einstein acknowledged this. He once said, "My formulas may someday be proven wrong, but logic and numbers never will," a reference to the irreversible nature of entropy. Now, let's talk about Einstein's theory of special relativity and what it says about time travel. Einstein proposed that space and time are part of a single fabric called space-time. In this four-dimensional model, time is treated as a dimension, just like length, width, and height. But there's a catch. We don't move through space and time the same way. We can move freely in space, forward, backward, left, and right. But in time, we're always moving forward, meaning we can't slow down or reverse time. In a space-time diagram, if you're standing still in space, your movement is entirely through time. That's shown as a straight vertical line. To go backward in time, you'd need to bend that line backwards, essentially making a U-turn. But doing that would require you to exceed the speed of light. And here's the problem. According to relativity, nothing with mass can reach or exceed the speed of light. Thank you for watching the video. Don't forget to subscribe and like. And if you have any questions or anything to say, make sure to comment it.